Alright, so as you all know, we are studying astronomy right now, which is the study of the universe. So let's take a minute and see what you know. You should have learned a little bit about the universe. So, what do you know? Well, by now you should know that our universe contains all space. So everything that's out there beyond our solar system is all contained in the universe. And also, you should know that the universe is mainly made up of empty space. There's nothing there. There's no atoms there. It's called dark matter. Scientists truly don't understand it yet, but all we know is most of the universe is empty space. We also refer to empty space as being a vacuum. So if you see vacuum on your paper, don't get all upset. I think there's two U's there. Okay, so that's what that means. It's just empty in space. And another thing you should know by now is that hydrogen is the most abundant element. Alright, so just a note, if you haven't started writing yet, please make sure that you're writing and taking these notes. Ms. Clay will be looking for them in your notebook, as will I. Alright, so let's look at what scientists believe started the universe. And the universe began in what is known as a Big Bang. To date, that is the best theory we have for the beginning of the universe. Remember, just because it's called a theory doesn't not mean that it is not true or that is not the way it happened. Of course, as more and more scientific technology becomes available, we'll know more and more. But to date, through everything we are doing currently, the Big Bang Theory is the best one that explains the origins of the universe. Well, why? Because we have evidence. And what is the evidence that points towards the Big Bang as the beginning? Well, one is our universe is expanding. And we can see our universe expanding because galaxies are moving away from us, and that phenomenon is known as a redshift. So the redshift in galaxies, and we'll talk more about that later. So the redshift in galaxies means they're moving away from us. What would be another word for that? Can you think of it? Well, we call it expansion. The universe is expanding. And another good proponent for the Big Bang Theory is number 2, which is what's known as cosmic background radiation. I don't know how many of you have ever experienced this, but if you turn on your TV and you're not on the correct channel, and you just get this fuzzy sound and stuff with no image but just little black lines and all that, that's truly cosmic background radiation that your TV is picking up. So it's picking up radio waves from the beginning of the universe. So I'm just going to put TV noise here. Okay, so those are the main proponents for the Big Bang Theory. As I said, as technology becomes more more sophisticated, we might come up with something new, but we've been investigating this for hundreds of years, and this is still where it's at. All right, so that's our universe, and that's how it started. So now let's think about the organization of the universe, because you guys did that yesterday, so you should be well aware of the organization of the universe. And this time we're going to attempt to go from the largest to smallest. So if we look at that, what's the largest thing out there? The largest thing out there would be the universe. And what's smaller than a universe? Well, this one you might not have picked up on, but there are little groups of galaxies, kind of like neighborhoods in the universe, and these galaxy groups are referred to as galaxy groups. Ours is a local group. So ours is called the local group. So actually we are in an area in the universe. If this classroom was the universe, also the science classroom, then our local group, our galaxy, the Milky Way, along with 39 other galaxies in this little local group neighborhood, would be about the size of a penny. So keep that in mind. So a whole neighborhood of galaxies in this classroom would be about the size of the penny. That gives you kind of an idea of how huge the universe must be. All right, so, and our local group, so then what's smaller than a galaxy group? Well, obviously a galaxy in itself is smaller. And our galaxy is known as the Milky Way. What's smaller than a galaxy? Well, actually the smaller than a galaxy would be a star system. A star system is like a star with various planets, moons, asteroids, comets, whatever, just like we have here. We call ours the solar system. All right, and moving on to the next smaller thing. Well, what's smaller than a star and its whole system would be a star by itself, and we call our star the sun. Smaller than that would be something like planets. Of course, we call ours Earth, but we have many planets in our star system. And smaller than that would be something like a natural satellite. And a natural satellite, our natural satellite, we refer to as a moon, or as the moon. Some planets in our solar system have many moons, such as Jupiter. Alright, so that's kind of a basic rundown. What would be smaller than that would be kind of leftover debris. Leftover debris meaning as our solar system formed, or our star system formed, things did not come together and form a moon or a planet, but they just kind of remained out there, such as the asteroids and comets and various other dust that just did never form anything. Alright, so let's focus for a minute on galaxies. As you should know by now, galaxies, there are three types. They're basically named according to what they look like. So we have a spiral, such as ours, and we'll talk a minute, an elliptical that looks pretty round or egg-shaped, and an irregular. So those are our three types of galaxies. Spiral has arms shooting off of it similar to a pinwheel. It can only have two arms. It might have multiple arms. such as this, but it all looks like a spiral. Elliptical, on the other hand, just like we said, it could be circular group of stars, or it could be more egg-shaped, but it is definitely what we would refer to as elliptical. Now, my solid dots here are not a good representation because remember, galaxies contain billions of stars. So my little dot does not show all the billions of stars that make that up. It doesn't show here either that all of these arms are made up of actual stars. Right? So that's not shown here, but that's implied. Irregular, well, that's what it looks like, what it sounds like. It's not regular in shape. It couldn't be classified as elliptical or in any way. It's not circular. It's not oval in shape, but it's just kind of a blob. And there would be our billions of stars for this one. And that would be an irregular shaped galaxy. A galaxy is literally defined as a billions of stars. Let's write that out. Billions of stars gases, debris, like we kind of talked about there, all bound together by what force? Yeah, all bound together by gravity. As of now, we believe that the gravitational force holding all these galaxies together is truly a black hole in the center. So we're not going to, well, we could write thought to have black hole at center. So that tells you right there, these are bound together by that gravitational force the black hole causes.